Hi, this is Brady Mellen, and in this presentation, I'm going to be sharing my knowledge about ionic compounds, diatomic elements, as well as molecular or covalent compounds. So the first compound I'd like to speak about is an ionic compound. In this case, I'm going to be using potassium and fluorine. So here is the chemical formula for this compound. The full name is potassium fluoride. Ion formation. So it starts off, well, each atom for each element starts off like this. So we have potassium, then we have fluorine. So ion formation. The singular valence electron in the potassium atom is transferred to this fluorine atom, and then two ions are then formed. So you have a potassium ion, and you have a fluorine ion. Next, I'm going to address the bonding between the two. So as you can see from up here, there are two opposite yet equal forces here, and they attract to form the bond between the two. So as you know, opposites attract. So since they have the same value, it would cause them to attract and come together to form this chemical formula. So next, I'd like to talk about a diatomic element. In this case, it is fluorine. So the formula here is F2, and that is because there are, in fact, two fluorine atoms. You can note that that diatomic elements are only comprised of specific nonmetals, as we'll see in a second, because of the amount of valence electrons in the outer shell. So the shape of each individual atom looks like this. And in order to fill the outer layer or outer shell, these two atoms have to come together and share a pair of electrons, these here. So I'll draw the final shape. And as you can see, the outer layers for each atom are completely filled when they share. And the bond between these two atoms is not due to any electric charge like an ionic compound. It's really just due to the filling of the outer shells, of each atom. Lastly, I would like to talk about molecular or covalent compounds. In this case, I chose nitrogen trifluoride, meaning that there's one nitrogen atom and three fluorine atoms, but the name is changed to trifluoride to indicate that there are three atoms. So the formula for this would be NF3, because after all there's one nitrogen atom and three fluorine atoms. You don't put the one here because it's implied. So the shapes of each atom, so the shape of the nitrogen atom, is like this. And the shape of each fluorine atom is like this. but remember that there are 3 of them. So the final shape looks something like this. And as you can see, just like the previous example, the outer shells of each atom are completely filled. The valence electrons of both the fluorine atoms and the nitrogen atom are shared in order to fill this outer circle or outer shell. And once again, it's not due to charging that these atoms are bonded together. It's simply because they fill each other's outer circles and create stability. And I'd also like to mention that in molecular or covalent compounds, there can only be nonmetals. I hope my explanations for each of the different types of compounds, was adequate and you were able to understand it. And yeah, thank you for listening.